those of you who joined later, I apologize for having such a nasally voice and not having my camera on. I've just had still a little bit of bleeding after the operation in my nose, so I am still recovering. Next week, I promise I will sound better and have camera on as well. Okay. Thank you for bearing with me. All right, let's go to this point here. So first of all, where should you be in terms of your content? Sid, where do you want to be? Come January when school starts again, what do you think is a realistic, a good deadline to be at in terms of your content?
I think like around finishing or like just about to finish mod 6.
Good, good. I'd agree. You want to finish mod 6. Mod 6 is not, look, there's parts of it that you will definitely need my guidance and fine tuning for, but there are large parts of it where you can learn and self-teach yourself. Historical theories of acids and bases, definitions, just getting comfortable. Because what that is going to do is if you've already learnt mod 6 by the time we return next term, I will blitz through mod 6 in literally about 4 or 5 weeks. Okay? That's going to leave us plenty of time to do 7 and 8. Because like I told you, chemistry is kind of like a pair, right? Mod 5, you've all finished it. It's all, quite breezy, not too bad. LCP, acids and bases, when we talk about titration, when we talk about pKa, Ka, will start to get a little bit more challenging. Mod 7 is going to be quite application-based, completely new stuff where you cannot build upon like this knowledge. It's going to be completely new in terms of how to think, how to name organic compounds. And then mod 8 is a completely different beast because you'll have to learn how to think about analyzing spectrographs, and you learn content and how to think about a completely new part of chemistry that is going to be largely challenging and unfamiliar to you. So the goal should be to get through this stuff as fast as possible so we have the most time to spend on this because that is what most of your exam questions are going to be based on. Okay, so first thing I would say is finish mod 6. I'm going to give you all access to the mod 6 theory books, and ideally, hopefully also post it across to you so you can annotate the heck out of it, finish that. I want you to have finished the mod 5 trial questions booklet and also at least had a start and ideally finished the mod 6 trial question booklet that I'm going to also give you access to. So that's where I need you to be by January. When it comes to routine, I told the biology class this. Q uses Notion. Can you hit the raise hand icon? Any of you use Notion? I had no clue about this stuff when I was in high school, but it has transformed the way I learn. Let me just quickly show you all. Me studying for my final year medical school exams, I went through. Look at how organized this was. So I'd structured it by topic, discipline, had questions, answer those questions, like exemplar answers, broke it down with diagrams, flowcharts. My entire learning, how I learned was all on this platform. You can't do that for the HSC. It's a little bit different. But what I want to share with you guys is I created a habits table. So every day you put in the habits that you want to get done. You check it off. And for you, it's going to be completely different. It'll be like study, 2 hours, one subject, and you can organize it however you'd like. And then for the different subjects, it'll have the percentage completion or your different habits, whatever it be. So I'll empty it and I'll make it in a HSC format for you guys, send it to you. But I highly recommend you try using it because, like I said, habits and consistency are way more important than just blazing through content when it comes to chem and bio. Good. Now, I want to ask you guys this question. Are you all confident with mod 5? You hit the raise hand icon if you feel at this point you've done enough questions about KSP, you've done enough questions about LCP, concentration time graphs, that you feel confident with mod 5. And be honest, because I want to know your general, like where you stand on this. Because that's going to shape today's lesson too. Okay, good. Jacob feels confident. Okay, and so for those of you who don't completely feel confident, which parts are quite challenging? I'm gonna put it down for us. Usually students say it's the KSP questions, concentration time graph questions. That tends to be the main things. things like common ion effect, and then maybe hard KQ questions. So, Rithanya, which parts do you still think you need a bit more fine tuning on? 1, 2, or 3, or is it a combination?
I would say 3.
Okay, Sid?
I'd say just doing more KSP questions.
Okay. Nikita?
You know those questions where it's like explain like the effect of like collision theory? I just get like really flustered and I put a bunch of random things down. It doesn't make sense.
It is challenging, collision theory, so I should have included that as well. Very good. Good. What is really good is you guys have diagnosed your learning challenges, which is the first thing. And what about you?
I would say like the Ksp stuff.
Okay. All right. So concentration time graph, not too bad. We won't do any of those questions then. All right. So guys, what we'll do? How about this? The first hour of today, we will spend fine tuning, finding really hard Ksp calculation questions, and we'll go through it, how to think through them. Then the second hour, I think it would be reasonable to start Mod 6, because the other thing you'll realize is you will get much more utility going out and doing those Mod 5 questions yourself, looking at the sample answers and improving. And you don't necessarily need me to hold your hand and guide you through every one of those questions after a certain point. So I think that would probably be the best bet for how we structure today's lesson. Is everyone happy with that? Good. All right. Now, first question I want to go through was Nikita posed a really good question. I thought this was probably one of the best KSP questions I'd seen. It was released a couple years ago, and every year some student brings this question up. So Nikita, do you mind posting that in the chat section if you've got it? Do you remember the question?
Yeah.
2 weeks ago.
Yeah.
Good. And we will start by going through that question. So just in the chat section here would be good. And I will go through it with you all. Like I said, the first thing I'm going to do is I'll always give you about 30 seconds to start the question yourself. And ideally, what I want is for you to have a plan of attack. The thing about chemistry is it's the same steps over and over again, pattern recognition, and at least having a plan during reading time for every question in your paper. If you can do that, you will largely be set for a band 6. So while we're waiting for Nikita, what I'm going to do is go through the trial questions myself and find and circle some more trial questions for us to go through. Nikita, just let us know once you've done that. I will just be circling some questions. I also want to stress, guys, the question I'm showing you are the hardest trial questions. So please don't be flustered if you find every question we're about to do challenging or most of them, because it just means I'm pushing you to learn, improve, and adapt. Sid, question?
I just have a question on like how we could effectively learn from our mistakes that we made in the.
Okay, very good question, and that's one of the most important things for science in general. What I did, Sid, was I actually printed out every single trial paper that I did, and I would do the paper in time conditions, and then I would mark myself in red, and then at the very front of the paper, I would list out every single key mistake I made in red. And what I also did was I had a separate book called my mistakes book. And in the mistakes book, I structured it by module, mod 5, mod 6, mod 7, mod 8. And I think hopefully you guys can do this on the internet. Is just you can copy paste the syllabus. And then every mistake you make, you can put it in red under the specific inquiry question at least for the modules. And so throughout the year, what will happen is you will have the key things that you keep stuffing up on that you need to improve for every single topic of HSC Chem. And then you can start removing mistakes when you're just so good that you're not making them at all again. So I'd say this is super helpful in terms of getting from a 90 to a 95 to potentially a state rank, which I think some of you can get if you really put the work into it. Does that make sense, Sid?
Yeah, thanks.
But you guys all need to make sure you're doing papers in time conditions and you are marking your papers, and you're marking it very strictly, like you are a really bad marker who wants to take marks off, right? If you do that, you will inadvertently improve. And that's probably the most important thing that got me from a high band 5 to a solid mark in Chem.
Okay, I've put it up.
Good. All right, let's go through it. Okay, so this is from the slides. I think I wrote this question up, but it was a very similar question to this in one of the trial papers. I think it was the exam choice trial. So again, guys, I'm not going to say anything. 30 seconds to get started and have some kind of idea or plan on how you're going to do it. And then I'm just going to start asking all of you for approach. Okay? Is that the question? Or do you not have it? Nikita, question for this, like what the exact question was. Do you have it, or?
No, that's just what you did in the video. Like you just put that and you answered it.
Oh, okay. So it must have been mass of lead nitrate.
I think you were trying to find the mass of lead nitrate.
Yeah, that's what I remember. Okay, good. So get started on that, guys. I shouldn't write it like this, because if I write it like this, it helps you out. You know mathematically what to get. The question would have literally just said, what is the mass of the lead nitrate? But I've framed the question for you already. You need the raise hand icon once you've got a plan of attack, just so I know. All right, let's get started. So, who has a plan? It's all right if we don't. Okay, what I'll do is I'll pass it on to Rithanya. Rithanya, let's say you don't have a plan, but it's writing time. Exam has started. You see this question. What is the first thing you do?
I write down what I have.
Okay. What do you have?
I said there was the concentration of.
I'm going to stop you right there. What is way more important than the data? What's the first thing you always do? Data won't make sense if you don't have the story. What is the first thing you do? Anyone? You all know this. I'm just stressing it because if you don't follow it in a hard question, it'll stuff you up. Sid?
The equation.
Good, right? I want to see the equation first and foremost. So if you finished all the modules in HSC Chem, the other hard part is going to be which module is this testing? I'm sure most of you can tell it's a KSP question because of the title. But if it weren't the case, you do really need to ask yourself, would you have known it was KSP and what would have told you it was a KSP question? So, Jacob, what part of this question tells you it's to do with solubility products and the equilibrium constant?
Because it asks like a faint precipitate is formed or
Very good. What does that tell you, Jacob? Faint precipitate.
It means that like a solid was formed.
Yeah, we'll come back to this because I told you all, when you see the word faint precipitate, there's one specific thing you need to be thinking. But good. The other thing is it's a precipitation reaction. So if you ever see a precipitation reaction, you've been asked calculation questions about it with any semblance of concentration involved, there's volume and there's number of moles, so there's concentration involved, it's probably a KSP question. Okay, but coming back to this, lead nitrate combines with potassium chloride to form lead chloride and potassium nitrate. And could I get, Ruthenia, could you balance this equation for me?
It's 2 KCl and 2 NO3. 2 KNO3.
Yep, good. Okay, good. All right. Okay, so we've got one equation. Is there any other equation you want to include? Sid, any other equation you want to include?
The ionic equation.
For?
Lead chloride.
Good, right? So if you've done enough KSP questions, you'd know this is an important equation that you might need to be using, right? Pb2 plus and 2Cl minus. Good. What is a KSP for lead chloride? Someone should have the data sheet on them. What is the KSP value for lead chloride?
It's 1.70 times 10 to the power -5.
Good. All right. Nikita, how did you know you had to use KSP for this question?
Because it says faint precipitate, so that means that equilibrium.
Good. The specific thing I want to hear is if you ever see the word faint precipitate or fine precipitate, you think this is a saturated solution. And only when it is saturated does it form this equilibrium that has a KSP value. If a solution is unsaturated, guys, there has been no precipitate formed. There is no reactant here for this equilibrium. This equilibrium only starts to form once you have a saturated solution, and then when it's supersaturated as well. But that's a different story. You will never have to deal with supersaturated solutions quantitatively, okay? So very important you all understand that. That's what I was looking for. Good. Now you can go to your data. So Anne, quickly tell us what data do we have? And tell me mathematically, what's M, what's V?
So we have that there was 250 mils of water and then 100 mils was added.
Okay. So equals 250 ml. So I need you to give it to me mathematically. So V of lead nitrate was 250. What else do we have?
There was 100 mils of the potassium chloride.
Okay, so V of KCl is 100. Keep going.
And then we also have the KSP, but I'm not sure I don't know what to do from here.
Okay. What about this value here?
Oh, would we convert that to like concentration or something?
Good. But before you don't, remember, we're not doing any calculations just yet. We're just writing all our data. Because if you don't write all your data, it gets very confusing because I wouldn't know what to do if I just had two V values, right? The second you've got an N, it starts telling you a little bit of a story on what to find mathematically. Okay, so let's say I'm stuck right now. What I would do next is I would mathematically frame the question. So if they said, what is the mass of lead nitrate? I would write M of PbNO3 equals to question mark, because this is a final thing I need to find. What else do I need to do? So we've done equation, we've done data, we've already been given moles, but if you haven't been given moles, you'd find moles. We've framed the question. What can we do once we've framed the question? Sid?
Would we find the concentration of potassium chloride? And
Yeah, so that's when you start working. Really good. But what you can also do is work backwards once you frame the question, right? So Sid, when you want to find mass of lead nitrate, what do you usually need to find before you find mass of something?
the moles.
Yeah, so now you know the question is really asking you to find the moles of lead nitrate, because once you find moles, you can find mass, and there's literally no way to find mass by itself. And then you can start thinking, well, how do I find number of moles of lead nitrate? What's the common ion linking this and this equation, everyone? You could possibly find number of moles of lead chloride. Finally find potentially the concentration of lead chloride, which is very possible from KSP. Do you guys see the backwards working that I've done? So what I've technically done is I now know if I find the concentration of lead chloride, I can find its number of moles in the total volume solution. I can then work backwards to find lead nitrate. And I can then work backwards to find the mass. So I've pretty much got a game plan already. Can you all see that? This is probably the hardest skill to build, but it is the most important skill. A really good student reading time can break down every question. Next thing I would say is if you're stuck, do a diagram, right? So let's quickly do a diagram so we really understand this, so we don't stuff up our V values, right? So what's being added to this beaker here? We've been given lead nitrate, and we've been given KCl, right? And what volume has been added for each? 250 and 100. I like to always do diagrams when there's volumes of individual solutions being added together. So what's the total volume of the solution? Good, right? We already have their concentrations. Good. So now we can start doing what Sid mentioned. So now you kind of don't even need to think. You just follow the flowchart or the steps that you've always been following. So Sid, as you mentioned, you see an N and you see a V. What can we find?
The concentration.
Good, right? So you can say, well, concentration of, go back here, KCl is going to be equal to N times V. Remember, please, when you're doing it yourself, always do C equals N on V first, because you can't imagine the amount of stress students that stuff up basic repositioning chemical equations. You do not want to be that student in the HSC exam. So always get used to writing the formula first. Good. So what is our answer? Someone would have done it by now. 0.1 times 100 times 10 to the power negative 3. What do we get? Come on, guys. What do we get for our answer?
Why is it N times V?
Oh, have I stopped it up? Yeah. C equals N on V. There you go. I wrote the correct equation and I stopped it up. N on V. Thanks, Sid. All right. So what do we get as our C?
1 molar.
Just
Liter.
1, exactly?
Yeah.
Okay, good. All right, so we've got C of KCO as 1 mole. What can we do with this information? Look at the equation at the top and look at the equation at the bottom. What can we do?
Find like the chloride.
Very good. Because if we have chloride ion concentration and we have KSP, we can find the concentration of lead ions. And if we can find the concentration of lead ions, we can work backwards to get to our answer. Does everyone see that? Exactly right. You have to ask yourself, well, why? What do I do with this KCl, right? It's like you're trying to put it in KSP. Yeah, good. So you can therefore say, therefore, the concentration of chloride ions in the solution is also going to be equal to, just pause for one moment because it is slightly moles of KCl divided by V. Sid, what V value did you use?
The 100 milliliters.
Okay. Is that the V value that all of you would have used?
Wait, do you just use the total volume?
Exactly. Jacob, where is the KCl dissolved in? Is it dissolved in up here or is it dissolved in this big solution?
Yeah, in the big solution.
There you go. That is why the diagram is so important, so you don't stuff up the V value. So I'd agree with Jacob. This KCl, even though it was delivered in 100 mLs, it ended up being in a solution which is 350. And that is where this whole KSP equilibrium is forming, because that's where the lead is already sitting for it to form the lead chloride. Does that make sense, Sid? So the V value you'd use would be, so N would be 0.1 moles, but the V value you'd use would be 100 plus 250 times 10 to the power negative 3. Does that make sense?
Yeah.
Yeah, good. Yeah. That's why diagrams help. All right, so what is our answer now for concentration of KCl?
I got 0.2857.
Okay, good. Did everyone get that answer? And Nikita, did you guys get the same answer?
Yeah.
Good. All right, so now we can say, well, concentration of chloride ions is equal to the concentration of potassium chloride, which is also equal to A moles per liter. Now we can move to the above equation because we've got concentration of chloride ions is equal to A. You've got this concentration, you've got KSP. Does everyone agree we can find this concentration here? Right? So now let's say, I'm going to label the equations to help us out. This is equation 1, this is equation 2. So you can say from equation 2, to help the examiner follow us, we can therefore say KSP is equal to lead concentration times chloride ion concentration squared. What are we trying to find? The lead concentration. Can everyone appreciate this? The lead ions that have dissolved in here are entirely due to this lead nitrate. Right? Lead nitrate is completely soluble. All of the lead ions here are from the lead nitrate. So if we can find all the lead ions here, we can work backwards and thus find the concentration of lead nitrate and then go back to find its mass. Good. If anyone has any questions, please do ask now because it's very important you understand what we're doing rather than just following the steps. Good. Okay, so what is KSP? KSP is 1.7 times 10 to the power negative 5 concentration of chloride ions is equal to A, but we're doing A squared. What is our answer for lead concentration? What do we get?
I got 2.08 times 10 to the negative 4.
Okay, good. What's the unit, Jacob? Moles per liter, moles, mass, grams?
Moles per liter.
Good. All right. Good. Good stuff. All right. So now we've got the concentration of lead ions is 2.08 times 10 to the power of negative 4 moles per liter. And what do I do now?
Would you just compare it to the original Ksp?
Okay.
Oh wait, no, you would convert it.
We've already used the original Ksp, the
grams.
1.7.
No, would you convert it to grams?
Okay. Would you convert it to grams? Because if you convert it to grams, Jacob, you just get the mass of lead. That's not what the question's asking us. They're asking for a different compound. That's why it's important to mathematically structure it, right? We need to jump from lead to lead nitrates. That's what I'm asking you. And moving on to you. What's the next step? What do I do now?
I'm not too sure.
That's all right. And where did this lead come from? That's my question.
So
Right?
it
You need to
is
understand it went to form lead chloride, but that is a product, right? Where did the lead actually come from? Which reactant?
the lead nitrate.
Very good. All the lead came from the lead nitrate. Do you agree, Anne?
Yeah.
So let me just give you a bit of a thought experiment. If I had one Lego block of lead nitrate, right? Lead nitrate is, this is what lead nitrate is. It's one piece of lead combined to two pieces of nitrate. If I drop one Lego block of lead nitrate in solution, how many blocks of lead would I release?
2.
Sorry, Anne, 1 or 2?
Was it 2 for the nitrate?
Not the nitrate, the lead. Remember,
Oh,
we
the
don't care
lead
about the
one?
nitrate. Yeah, there'll be one block of lead, right? The block is an analogy for moles. And if this is in 1 liter of solution, 1 mole of lead nitrate would release 1 mole of lead, or 1 mole per liter of lead nitrate would release 1 mole per liter of lead ions. So, and if I had X moles per liter of lead nitrate, how many moles per liter of lead would I release?
Of lead.
Yeah.
X.
X, exactly. Now, and what do we have right now, right in the clasp of our hands? We've already got the concentration of lead. We worked it this way in this analogy. Can we not work backwards?
So would you do 2x for the nitrate?
Good, but do we need to solely find nitrate? Can't we just say, well, the concentration of lead was equal to this value, which is B. Let's just call it B, right? So concentration of lead ions is equal to B, which is equal to the concentration of lead nitrate. Why do I need to find nitrate as well? Does that make sense, Ed?
Could you explain the last line you just did right there?
Yeah, the last line right here.
Yeah.
It's quite literally this analogy here, right? Which is, again, if we have 1 block of lead nitrate and I dissolve it in solution, I will release 1 block of lead. Or if I have a concentration of 1 for lead nitrate, I will end up with a concentration of 1 for lead ions. Do you agree, Anne?
Yeah.
Same way, if I had a concentration of B moles per liter of lead nitrate, I would release a concentration of B moles per liter of lead. What we've just found is that the concentration of lead is B. And so now what I'm doing is we work this way. I'm just working backwards. I'm saying if we have a concentration of lead that's equal to B moles per liter, the concentration of lead nitrate must also be B moles per liter.
Right. Yeah.
Does that make sense to everyone? This is very, very important conceptually to understand. when you do more and more questions, this will make. I would urge you all to do this question again from scratch once class finishes, because that's the true test of whether you understand it. Okay, but does anyone have any questions conceptually at this point? Good. Nikita?
I have a question.
Yeah.
So my question was basically, you know, with these KSP kind of questions, right?
Yeah.
If you're given like the concentration of like Cl minus, especially when the ratio is like 1 to 2, why would it not be in ratio? Like, why wouldn't you care about the ratio? I don't know if that makes sense.
Oh, like you're saying the concentration of lead is half that of Cl minus, right?
Yeah, yeah.
I'm just quickly seeing if we did make a mistake accounting for that. Okay, so the time you would care about ratio, Nikita, is if they told you, for example, the concentration of lead chloride that dissolved was equal to X. Because then when you find KSP, KSP is going to be equal to lead, and is going to be equal to chloride ion concentration squared. Do you agree?
Yeah.
But if you have X moles per liter of lead chloride, you'd release X moles of lead, but 2X moles per liter of chloride. That's the ratio that you're talking about.
Yeah.
So then when you sub it in, it's going to be X times 2X squared. That's when the ratio counts. But that's not how this question works. We didn't go from here to finding KSP. This question was very different, in which they gave us a precipitation reaction with chloride, and we used that chloride and we sub that in. So 2X was A. That was 2X.
Yeah.
And we were asked to find this concentration here. And the reason they're not correlated, they're not X and 2X, because where did the chloride come from? Chloride came from potassium chloride. Where did the lead come from? It came from lead nitrate. Those are two different compounds that don't need to be in ratio with each other. They're two completely different compounds with different C and V values. Does that make sense?
But then wouldn't the concentrations at equilibrium for these kind of questions always be the same?
No, it wouldn't. So they would only be in ratio when you have lead chloride itself, which this is what we don't have. We did not have X. If we had X, then the amount that dissolved would be X and 2X. But the issue here is we had two different substances contributing one completely random Cl2 minus amount and one completely different lead amount. The only thing that needs to be constant is KSP.
Okay, so for a question like this, if there was like a limiting reagent for like one of the things, then would you have to take that into consideration?
No, you would not need to.
Okay.
You just solely sub in the ion concentrations, and you can find the other. Let me just confirm. I'm just going to see if there's any other question types where you wouldn't need to account for limiting excess reagents. No, literally for all of these questions, guys, you would literally just find, if you were asked to find the, let's say you were asked to find the concentration of chloride ions when you're given lead ions, you'd literally find chloride ion, when you'd literally use the lead ion concentration, you'd use KSP and find chloride ion concentration. Yeah, so you wouldn't have to use excess limiting for this question.
Yeah. All right, thank you.
Good question. All right, so coming back to this, concentration of lead nitrate is equal to the concentration of lead, which is B. So that's equal to B. We now know the concentration of lead nitrate. Sid, do we know the volume of the entire solution?
Yeah, 0.35 liters.
Good. So what can we find?
The amount of moles.
Good. And if we have number of moles, what can we find, Sid?
The mass.
There you go. So I'm not going to say anything. I want all of you to do this part yourself. So go from concentration of lead nitrate. I want all of you to tell me what is the mass of lead nitrate for this question. This was an MCQ question, by the way, which is it's unfair for this to be 1 mark. It's at least 3 marks. But trial papers are like that. So just be ready that questions 16 to 20 of MCQ, some of them will be quite long-winded. So once you've got an answer, please hit the raise hand icon. All right, Sid, how did you go?
I got 2.41 times 10 to the power of -2 grams.
Did everyone get the same answer? And Sid, how many sig figs would your final answer be to?
It'd be 1.
Yeah, so it would be 2 times 10 to the power of -2 grams. Good. Did everyone get the same answer? Does anyone want me to explain how I go from concentration to mass? We've got concentration of lead nitrate is equal to B, the volume in total in this entire beaker, which is where the whole lead chloride has dissolved, and that's where the lead nitrate is also present, right, is equal to 350 times 10 to the power -3. And so then I just go, well, C equals N on V, N equals to CV. That's equal to B times 350 times 10 to the power -3, and then just go from N to mass. Britannia, did you get the same answer?
Yes.
Good. Jacob, same answer?
I'm just double checking real quick. Hold on.
Okay, no worries. Good. This is a hard question, guys. It is meant to have taken us half an hour because you need to ask a ton of questions. So don't feel unproductive at all. Every time I go through this question, it creates a lot of prompt questions, clarification, breaking down. But what is so important for you all to learn is these steps to follow whenever you're stuck. If you don't apply this out of stress or just not incorporating it, very hard to do well on chem, because chem is just routine, repetitive, same things again and again, just slightly modified. You need to understand it conceptually as well. So that's why diagrams help so much. Any questions at all? And just to clarify, like I said, the reason limiting excess reagents don't matter for these questions, guys, is especially when you have fully, completely soluble ions like KCl and lead nitrate. It doesn't matter who's excess or limiting. Who's excess or limiting is going to affect the amount of this reagent made. But the issue is, this reagent that was made, right, it is also dependent on Ksp. Not all of it will dissolve and be aqueous. Some of it will become aqueous, some of it will become solid. So what you would need to find is you need to find the total concentration of lead ions here. You need to find the total concentration of chloride ions here. Okay, and then you can just put it into your Ksp. You can find Ksp, or then if you know the Ksp for that particular temperature, you can work backwards from the Ksp as well. Good. Okay, let's move on. That was a hard. This is a hard question, so I'll see if I can find an easier one for you. But Okay. I guess the only question is this one. This question doesn't actually have much to do with KSP. This is more of a acid-base calculation question. There's not much additional information you need to know. So maybe just we'll come back to this question for us. So we'll pause right there. Let's do one of these questions. See if we've got. Question 14. So this is very similar to the previous question we did. You can't use, well, you tell me, can we use ratios or not for this question? But start by doing the question. Give you all about 40 seconds to start. All right, let's get started. So, Nikita, what's the first thing we always do?
Write out the equation.
Good. So, what is the balanced equation, Nikita? What are the two equations you're going to include?
So sodium hydroxide, which is so you do 2 NaOH, and then you'd add it to Ca. Yeah. Forms 2 NaNO3 and then CaOH2.
Do we know which one's the solid, Nikita?
Is that a solid? The hydroxide?
Calcium hydroxide, yeah. So always remember, group 1 metals always soluble, nitrates always soluble. So that's it. I think, Sid, you had some kind of mnemonic last lesson. Got the mnemonic.
Well, what's a mnemonic?
Oh, like a little acronym that you had for remember.
Snap.
Snap, right? I think it was like sodium, nitrate. What was A?
Acetate.
Acetate, nice. Acetate, and then
Ammonia.
P.
There's two A's, so ammonium and
Oh, okay. And what's P?
potassium.
Oh, it's hard for me because I think very like chemical formula, and I think K for potassium. Okay, that makes sense. Yeah. Acetate, nitrate. Yeah, that's a very good one. Instead of S, it should just be all group 1 metals. Literally anything with a +1 charge, that's why ammonium is +1, is always going to be soluble. Ammonium, sodium, potassium, nitrate, acetate's always soluble. Good. Anyway, coming back to this, that's the first equation. What's the second equation? Similar to the previous question, Rithania. What's the actual Ksp equation we care about?
Is it the calcium hydroxide?
Good, right? Calcium hydroxide solid is going to ionize to form calcium ions and the 2 hydroxide ions. Very good. Good. Straight away go to your data sheet. What is the Ksp value? Because see what they've asked you. What mass of sodium hydroxide will cause precipitation to start? The second a precipitation starts, aka there is a fine precipitate, you know it is. What's the S word we're going to use? Saturated, right, guys? And if it's saturated, you'd be using Ksp. So what is the Ksp value for calcium hydroxide? Who's already got it?
5.02 times 10 to the power of -5.
Good. All right. So we've got Ksp 5.02 times 10 to the power of -5. Good. Now let's put our data in. So what data do we have? Anne, back to you. Tell me mathematically, Anne. What's N, what's a B, what's C?
So we've got the volume of sodium hydroxide, which would be 0.2 liters. And then we've got 1 mole, no, 0.1 mole of calcium nitrate.
What is that? Is that C, N, or V?
Pardon?
Is that C, N, or V? Moles per
The
liter.
concentration?
Good. Right? So important you write the correct letters. So C of CaNO3, 2 is going to be equal to 0.1. Good. V of CaNO3, 2 is going to be equal to 200 times 10 to the power of -3. Good. So, Anne, what are you going to do now? Frame the question, Anne. What are they asking us to find?
Find the mass of sodium hydroxide.
How will you find the mass of sodium hydroxide, Anne? Now we're going backwards. We're working backwards. We framed the question. What do you need to do to find mass?
We find the concentration of the hydroxide ions.
Find the concentration of hydroxide ions. Okay. How would you do that? So see, what you did just then, you jumped a little bit because we're talking about sodium hydroxide. You jumped to the hydroxide ion. Let's stick to sodium hydroxide. What do you need to do to find M of NaOH?
You need the moles.
Of NaOH. Exactly, right? And then usually with these kinds of concentration type of questions, you probably find moles working backwards because you've got the total volume. You've been given, if you draw a little diagram, you've been told that 0.2 liters was added to 200 ml. So what's the total volume? 2.2, right? So we could probably find the concentration of sodium hydroxide and then find the number of moles of sodium hydroxide and then find mass. Then to find the concentration of sodium hydroxide, you're right, we could find the concentration of hydroxide ions. How would we do that, Anne?
You would use the Ksp value that's given on the sheet.
Yep. And how would you find the calcium concentration?
With the Ksp value as well.
Oh, that would be, you wouldn't be able to find it with a KSP value.
With the because we've got the concentration and volume, so we'd use that to find the moles.
Good. That's it, right? So do you see how you've already got a plan of attack now? That's what I want you guys to all be building. This is very similar to the previous question that we did, right? So good. We've got now, all right, we've got a C and a V. Britannia, what are we going to do?
Find moles.
Good. So number of moles of calcium nitrate is equal to, if they don't stuff it up this time, C equals N on V. So N equals to CV. So 0.1 times 200 times 10 to the power negative 3. What do we get quickly? What's the number of moles of calcium nitrate?
Zero point 0.02.
0.02. Good. Did everyone get that? Good. What is a new concentration? What is a concentration of calcium nitrate? Because it's not this. This was a concentration. This value here was a concentration of calcium nitrate in this volume. Remember, where is the calcium nitrate swimming in now? It's swimming in 2.2 liters. Do you all agree? The calcium nitrate was added. In total, there is, oh, sorry, it's not 2.2 liters. What am I saying? The volume total is 200 ml here. It's just a quantity that's being added. My bad. In terms of volume, what we can just write is volume is 200. We've got the number of moles of calcium nitrate. Okay, so we haven't been given volume. This is not right. V of NaOH. That's not right as well. It's just a mass that was added. Okay, good. Apologies, not to confuse you guys. There's no volumes being added in this question, so there's really no need to draw a diagram even. But good. Okay, what do I do now? I've got concentration of calcium nitrate. I've got volume. I've got number of moles. What should I do?
Use the KSP and
Yeah.
then the concentration and then like arrange the equation.
So my question is, did we have to find moles of calcium nitrate? Was that needed?
No.
Yeah, not really.
Not really.
I'd say not really, because the only time you'd have to find number of moles is if you were then going to find the new concentration if there was a volume of NaOH as well added. Does that make sense, Nikita? Because then this concentration would have been diluted. But essentially what you can just do is you go, well, okay, concentration of calcium ions in the solution is just going to be equal to the concentration of calcium nitrate in the solution, which we already have. There's no additional volume from NaOH, just as a quantity of NaOH was added. You assume it's a solid in that situation, right? So that's just equal to 0.1. And so we just sub that in. So you go, okay, well, KSP, what is it equal to? It's equal to concentration of calcium multiplied by concentration of OH minus squared. We know the KSP, we know the concentration of calcium. So you can therefore, what is the concentration of OH? You go, well, OH minus is equal to KSP divided by the concentration of calcium, and then we square root everything. So what do we get for our concentration of OH minus?
.0158.
Did everyone get this value? 0.0158. Sid?
I got a different answer. Let me check again.
Okay.
Wait, no, I did it wrong. It's 0.0071, I think.
Same answer, Sid?
Yeah, I got 7.2 times 10 to the power of -3.
Okay, sure. Whatever the exact answer was, let's store that as A. Good. So I'm just going to put a line and continue the working out on the left-hand side. Okay, we've now got the concentration of OH minus, and I want you to make the jump now. If we've got the concentration of OH minus, what can we find?
The concentration of sodium hydroxide
Good, which is equal to?
equal to 0.0072.
Good, which is also equal to A, right? And if you've got concentration of sodium hydroxide, what can we find?
The moles of sodium hydroxide.
Good, because you know the volume of the entire solution is equal to 200 ml. 200 times 10 to the power -3, right? So can someone tell me, we've got C and V, what's the N of NaOH? Therefore, tell me, what's the answer? Is it A, B, C, or D?
I got C.
Good. Good. Jacob, what about you?
Wait, I'm not gonna lie, I'm a bit stuck on what to do now to get the answer.
Okay, no worries. What do you want? What stage are you on, Jacob?
We have the volume and then the concentration. So once you find the number of moles of sodium hydroxide, right?
Yep. What did you get?
So that's just C times V.
Yep.
So it'd be A. So A times and then the volume.
Yep, that's right.
Okay.
And then you just use number of moles equals mass and molar mass to find the mass of NaOH.
Right.
That's it. So, Sid, you said C?
Yep.
Good. So now you guys are understanding this is a completely new question type to the other questions we've done on KSP, where they give you a precipitation reaction. They give you information about one of the precipitants. Just appreciate this question type, because once you identify the question type, these questions become very easy. You're given a precipitation reaction. You've been told to use KSP because it's saturated, and you've been given information about only one of the reagents. And you'll always do the same thing every single time. You'll find the concentration of that reagent, so this one here, and specifically the ion in that reagent that is in common with the KSP equation. And then you'll use KSP and this ion concentration to find the other ion. And then you'll work backwards to find usually mass of the other reagent. It is a very common question type, especially in trials, and it's probably the harder KSP question type that a lot of students find challenging. But now you've identified it, guys, I think you've done every single possible KSP question we can do. There'll only be slight nuances when it comes to acid-base questions, and you learned that in Mod 6. Good.
The answer wasn't like exactly the same for the question.
All right, let's have a look and see if the solutions are.
By the way, the question is D. Sorry,
The answer was D.
Yeah.
Yeah, no, that's what I got as well.
Okay, good.
I have a question.
Yep.
So you know how you found the OH concentration, right?
Yep.
So you know how you said, like, you're talking about like the ratios and all that.
Yeah.
Why would you? So if you got like the OH concentration, would the OH concentration be the same on both sides of the equation?
Oh, do you mean like this side and this side? Is that what you're referring
Yeah, is
to?
that because you were explaining that and it kind of doesn't make sense to me.
Oh, okay. That's your question. Okay. First of all, we are not doing anything with this ion actually, right? What we found, this OH concentration we found is the soluble OH.
Mm-hmm.
Does that make sense, Nikita? We didn't find the solid precipitate locked up as OH. So we actually did not find this. Does that make sense? All we did was we used Ksp to find the total amount of OH minus ions that are floated that were present in the solution. That's what we found. And all of those OH minus ions that were floating in solution came from this OH. So we didn't have to use any stoichiometry and do the whole half, if this is 1, this is 2 parts, that kind of thing. Does that make sense?
So they all came from that, and then
All the OH came from this. Exactly that.
and then that would be like you wouldn't do like. Okay.
Yeah, you don't have to do any like stoichiometry or anything. You're not dealing with this OH2 here.
Mm-hmm.
Yeah. Yeah. Good. Because even in this equation, guys, when you find this value, let's say you find the concentration of this here, this is a concentration of calcium OH that dissolved, because then that goes on to form this. You know when you say let this be equal to x, therefore this is equal to x, therefore this is 2x? This x is the amount of solid that dissolved. That is what you're doing. You're not actually just finding the actual solid mass and then dividing it by volume to get concentration. So it's a bit of a difference. Does that make sense?
Yeah, it makes sense. It makes sense.
Yeah. It's a lot of conceptual stuff and nuances with these questions, but yeah, it's the same principle. Good. All right. What I guess you guys to do now? Take a bit of a 5-minute break, where we'll come back to. We can come back to Mod 5 next lesson. What I'll urge you to do a ton of practice questions. Come to me next lesson with specific Mod 5 questions you want me to go through. That way I can kind of tailor our approach and our confidence in Mod 6 based on your weaknesses. And I think in the meantime, we should be fine to start Mod 6. Now, I'm not trying to rush
Wait,
Mod
I have
5.
a question.
Yeah.
Okay. So if you go to the Mod 5 booklet, right? The solubility where you give us like this is soluble, then this is like kind of soluble.
Partially.
Yeah. So you know how you said solubility is like grams per 100 grams or like 100 milliliters?
That's not just solubility is a very broad term, right? That is one measure of solubility. If you say something like grams per 100 ml, that's not solubility. What that actually is it's a measure of concentration called percentage weight / volume. That's grams per 100 ml. That is one way to measure solubility, right? You could also measure solubility in moles per liter. They're all just different measures of the same thing. But yeah, keep going.
Okay. So basically like I was really confused because you said 1 gram per liter would be soluble.
Yeah.
Like on the book it says that.
Yeah.
But that doesn't make sense if it says 1 gram per 100 milliliter is soluble, then wouldn't it be 10 grams per liter?
Where does it say 1 gram per 100 ml is soluble?
I don't know, I just thought that.
No, that's no. So what I was saying in the book and what the book is stating is you previously learned, barium hydroxide is soluble, but magnesium hydroxide is insoluble. What the book is telling you is there is no such thing as soluble, insoluble. It's not a polarity or a dichotomy like that. Solubility is a spectrum in grams per 100 ml or grams per liter or however the heck you want to measure it. But the standard cutoff that textbooks and chemistry uses is that if your solubility is greater than 1 gram per liter, or ideally greater than 10 grams per liter, you're soluble. If you're between 1 gram per liter and I think it's 10 gram per liter, you're
Mhm.
partially soluble, and if you have a solubility less than 1 gram per liter, you're termed insoluble. That's what it's
Right.
saying. I think the 1 gram per 100 ml you got, I'm not sure where you got that from, because I've not seen that as a
Yeah.
cutoff solubility.
I think it says that in the textbook because I've definitely saw that somewhere. And then I have another question.
Yep.
So with our school, they're gonna do like absorption, and then like the A is like proportional to ELC. The graph.
The Beer-Lambert, that's called the Beer-Lambert equation. Yep.
Yeah, that. And then there's like the absorption and concentration graphs.
Yep.
Yeah. So I had a question about those. I don't understand like why they have like I don't understand the concept.
Sure, we'll go through that. We can go through that when we come back. So, guys, just reference to all of you. The Beer-Lambert equation, it's not too directly relevant to Mod 5. You learn it from scratch in Module 8. The reason it's taught in Mod 5 is, well, can anyone tell me where it's taught in Mod 5? Sorry. Yeah, where in Mod 5 is this relevant?
Is it the iron thiocyanate one?
Calculating the K constant. Yeah, so you use this in colorimetry, and we're going to talk about that. I'll discuss that very briefly after your break, okay? Take your break. We'll come back at about 5:26-ish, and we'll go through the Beer-Lambert equation in a little bit more detail, just what you need to know for Mod 5, because you do need to know a little bit. And then we'll start Mod 6. Good. All right. See you guys in 5. All right, when you guys are back, you just hit the raise hand icon and we will continue. Thanks, Jacob. Good. Okay. Let's start by talking a little bit about the Beer-Lambert equation. So the Beer-Lambert equation is probably one of the most focal concepts in spectroscopy. What is spectroscopy? Jacob?
I remember it's like using light and then using colors to determine like concentration or.
Yeah, spectroscopy is the study of light, or using light to study matter. That is what spectroscopy is. You'll often hear the word spectrometry, which is when you're actually quantitatively measuring information when light hits matter. The terms are often interchangeable, but you'll often see in textbooks they use spectrometry and spectroscopy interchangeably. But essentially, we shoot light at matter, and that gives us information about the matter. Does that make sense to everyone? The other thing I want you all to kind of steer clear of is, rather than using the word colors, just think about what light is. I'm not just talking about visible light. Sid, what is light? Breaking it down broader. What form of wave is it? What are the different frequencies? Or
It's a electromagnetic wave.
good. Good. So it's an electromagnetic wave that varies significantly in frequency, and it has different wavelength types, right? So the characteristic properties of light is it always travels at c, about 2.97 times 10 to the power of 8 meters per second. It is varying in frequency and wavelength. And this formula is to show you that the frequency is directly proportional to the velocity of light, and the wavelength is inversely proportional. And we have completely different subtypes, right? So we have everything from the highest, which is gamma, X-rays, UV, going to visible, infrared, microwave, radio waves, etc., right? But there is a big frequency, and visible light is just one small component of the entire electromagnetic spectrum. So as long as you all understand, when I say light, I'm not just talking about colors, I'm not just talking about visible light, I'm talking about the entire spectrum, and we use different types for different types of matter. Coming back to this, we'll talk about what this Beer-Lambert equation is all about. So this is the equation, and it's actually a law, and it makes a lot of sense when you think about it, right? So what this is talking about is absorbance, right? Which is the amount of light intensity that decreases when it passes through matter. Let's say you've got matter right here. This is your container, and you've got one particle. What's going to happen is there will be an intensity before the light travels through the particle that's approximately about 100%. What happens afterwards is the intensity of the light is going to be less than 100%. And we use the intensity of the light before and after it passes through the sample to calculate absorbance, right? If there is a greater reduction in intensity after it passes through the sample, we say the absorbance is greater. Absorbance is just how much light has been absorbed. Does that make sense? Now, this formula is just telling you the factors that determine the amount of light that's been absorbed, right? So the most important thing you'll need to appreciate is the C. What does C stand for, Nikita?
Concentration.
Exactly, right? So if I have one particle of matter, let's say every particle absorbs light, maybe let's say 3% of light's intensity. If I only have one particle inside this sample or this chamber, the light intensity will just go from 100 to 97%. But if I have two particles, it'll drop to about 93%. If I have three particles, it'll drop even more. And as you can see in this fixed volume, what's happening is the number of particles is increasing, aka the number of moles, the concentration as well. So this formula is just telling you that the absorbance of light increases directly proportionally to the concentration of that sample. These two words, this is not an E, this is called epsilon, right? And what epsilon stands for is this term called molar absorptivity. And this is just substance dependent. As you all know, an atom of copper would probably absorb a different amount of light than an atom of diamond, which is an allotrope of carbon, which would absorb a different amount of light compared to an atom of bromine gas, right? Different atoms, due to their different structures, are going to absorb different amounts of light. And so that's what the molar absorptivity is dependent on. The epsilon depends on the sample, the element that you use. The L is just the path length. Path length usually, especially when you pass the sample to colorimetry. So let's say we're talking about colorimetry right here, right? So the light, which is a visible light, is going to pass through a cuvette. So do you know how wide a cuvette is? In a colorimeter, those are those rectangle cartridges that contain the solution that you're analyzing. Any idea what the path length is?
1 centimeter.
Exactly, right? So L just becomes 1. And so this is just to teach you that epsilon and length are constants. They're technically what we K for a constant, right? Epsilon depends on the sample. Length depends on the cuvette, which is not going to change. And so the real thing that this Beer-Lambert equation is really teaching you is the absorbance of a solution is directly proportional to the concentration of that solution. And that makes a lot of sense. If you have a greater concentration of iron thiocyanate, right, it's going to absorb the color yellow to a greater degree and reflect the color red to a greater degree as well, right? So that's what the Beer-Lambert equation is. That's all you need to know for this stage. Calibration curves, etc. You'll learn that if you do the iron thiocyanate experiment. If you don't, then you don't need to be tested on it, or you can't be tested on it. Akita, does that make sense?
Yeah, but then I was talking about the graphs. So does that mean like it just goes like it just like when you're reading it, right? It kind of, so like for example, if it's like it gives you like an absorbivity, and then it asks you to figure out like
let me help you out with this kinds of questions, right? Usually what you do, right, is for colorimetry or any kind of spectroscopy, what we do is the first step, everyone, is we put standard solutions through colorimetry, standard solutions. Okay, so those are solutions where we know their concentration, right? So what I'll do is I'll get a solution that's 1 mole per liter, a solution that's 2 moles per liter, a solution that's 3 moles per liter, and I will find its absorbance, right? And let's say at 1 mole per liter, the absorbance is 1, 2 moles per liter, the absorbance is 2, 3 moles per liter, the absorbance is 3. What am I doing? Can everyone see what I'm trying to do? I create what's then called a calibration curve. So the first step is we always put standard solutions put through the colorimeter, right? And that we use that to create a calibration curve, which is just a line of best fit. That's what a calibration curve is, line of best fit. Okay, then what we do is we put our sample solution that we want to know the concentration of, right? But we don't know the concentration. So we then put our sample through it, and we will get an absorbance. Remember, a colorimeter, the only thing it's going to tell you is A, absorbance. And it'll say the absorbance is 2.7. What we'll then do is we'll go, okay, well, if the absorbance is 2.7, I've got my calibration curve. The concentration must be this amount right here. And so that's how you can go from absorbance found on colorimeter and the calibration curve used to find concentration. That's literally all you'll be doing. That's pretty much all you need to know about calibration curves. This is important for all you guys, because if you do get an exam question with a table and you're asked to graph the line of best fit and then find concentration, hopefully now you know what to do. Does that make sense?
So how does this, like, how is that going to be used in, like, you know how you said it's going to be used for the K value?
Well, how do we find a K value? We create what's called a Rice table. Do you agree, Nikita?
Mhm.
So what you'll then be doing is you have A and B going on to form product C. How
Yeah.
will you know the equilibrium concentration X of product C, which is iron thiocyanate? How would you find that out? You'd know initial concentrations of A. So you'd know this amount. You know this amount because you add those, but you have no idea what the equilibrium concentration of iron thiocyanate is. Do you agree?
Can't
That's
we
what-
just know how much we put in?
But that's not how it works, because what ends up happening is A plus B forms an equilibrium with C. Just because you know you put in 1 mole of this and 1 mole of this doesn't mean you make 1 mole of this, because it's an equilibrium. You make less than 1 mole.
Oh, right.
Right? So to
Okay.
find equilibrium concentration, you need to use colorimetry to find this, and then you know initial concentration is 0. So then you just simply fill in your Rice table and you got your answer.
Okay. So that's why you use the absorbability.
That's why you have to use the Beer-Lambert equation. And well, you're not really using the Beer-Lambert. We're using it indirectly, everyone, because when we're creating this line of best fit, we're finding K, the gradient. We won't actually use this equation, but as long as you understand, that's what the A equals KC. It's a Y equals MX graph pretty much, and you're finding M, the gradient, through this line of best fit. Good. Yeah. All right, let's move on to mod 6, acids and bases. I'm going to give you all a couple of seconds to read this content focus, because there's quite a bit to it. And I've already underlined the key terms for you, but I'm going to ask you for your definitions. So what reactions do we care about with acids and bases? What are the definitions of an acid and base you know? What is pH? What are indicators? Because you need to know what your baseline knowledge is before we go and add on to that with a lot of new concepts and theories. I'll also tell you what's extremely high yield. So have a very quick skim of this. About 10 seconds, I'll ask you what your definitions are. All right, let's go to Britannia, what's your definition of an acid and a base? It's hard. It's a hard question, but
Acid is anything with the hydrogen, right? Gas.
an acid is anything with hydrogen. Is that what you mentioned?
No, not anything with hydrogen, but that has hydrogen gas.
That has hydrogen gas? Okay, close. Look, I want you guys to find out what your current understanding is. I don't care whether it's right or wrong, because that's why you're learning this. Okay, so anything that has hydrogen gas, you're very, very close. Anne, on to you. What's an acid?
I was gonna say pretty much what Rithani said, but I thought it was ions.
Good. I would agree with that. I'd say the current understanding that you should have coming into this module is that an acid is a compound that releases hydrogen ions. It's in a very specific solvent. What solvent am I talking about?
Water.
Water. Good, right? Because you're going to all soon learn that this is an issue. We can't have the definition of an acid that's bound or restricted to a solvent like water, because some compounds act as acids in different solutions. You can have compounds that act as acids in bromine water, but then act neutral in water, right? And so our current definition of acids is very restricted, and you'll learn there are new definitions that we have. for acids and bases. So very good. So water, or you can say in aqueous solution, because that's dissolved in water. So then what's the definition of a base, Jacob?
So a base would be where it releases hydroxide ion.
Releases hydroxide ions in water as well. Very good. Or aqueous solution. Good. But then you're going to soon find out that compounds like calcium carbonate. Jacob, do you see a OH in the structure of calcium carbonate?
No.
No, but you learn if you dissolve it in water and if you taste it, it's going to be bitter just like a base. When you rub your hands in it, it's going to foam just like a base. When you measure its pH, it'll be greater than 7 just like a base. So I'm just highlighting here the definitions that we have currently are flawed, they're limited. They have a lot of cons related to them. That's why you're going to be looking back at history to see what we first understood about acids and bases. So what are some of the characteristics of acids and bases? Nikita, what are some of the properties of acids and bases?
So is like acids like sour?
Good.
And then I don't know, but you know that the red and the blue thing?
Okay, there's litmus paper. So there is
Yeah.
a solid indicator called litmus paper, and this litmus paper will turn, acids will turn red in this litmus paper. It's a very specific one. So I'm not going to include that because you'll learn it later, and it's not too.
Yeah.
What else?
Bases are like soapy, like you said.
Yeah, bitter, soapy. Which one's worse to have in your eyes? A bit of a not too relevant question, but quite scary because you definitely can get acid or base in the eye. The answer is base. We're more worried about, it's called caustic burns rather than corrosive burns from acids. That's because bases continue to eat through the tissue of the eye, whereas acids will neutralize a bit faster and stop. Not relevant at all to your HSC, but just a bit of a, that's one of the use cases that I have for acids and bases. But let's pause for a minute and now think, why are we learning about acids and bases? Why are they important? Because if you don't know why you're learning these concepts in chem, you won't really be motivated to learn and understand it, right? So where do we use acids and bases in society? Because if we don't use it, then we shouldn't be learning it here, right? We're wasting time. We're wasting a term. Jacob, what are the uses of acids and bases?
We use them in like cleaning products, and then your body also has like hydrochloric acid to like, I'm pretty sure, break down food, right? Or in the
Why
stomach.
okay. Why should I care? That's the question. Why should we care about acids and bases? All right, cleaning products, but I'm not going to really be a cleaner, and I don't want to start a cleaning business. So cleaning products, cool. I think, yeah, very good. HCl is in stomach acid, so it's very important in digestion. So those are going into healthcare. Acid base is so important to understand if you go into healthcare, right? It's a basic literacy, and we'll talk about that shortly. Stomach acid. What else? What else? How do we get around? Transportation in cars. Does anyone know what kind of battery cars use? It replaces every 40 years. And it's quite interesting because when you use the electricity in your car, that consumes the battery. But when you drive, that forces a reverse reaction that will then store more potential energy to use as electricity. Does anyone know what acid that battery cars have?
Is it sulfuric?
Yeah, it's sulfuric acid used in your lead acid batteries. And it lasts about 40 years. I don't know how often we're going to use it if we're going to electric cars, but what else? What else do we use acid for? Give you a little hint. You and I probably wouldn't be alive today if it weren't for this use case of acids. Let's go back to the Haber process.
Nucleic acids. Sorry.
Okay, no, I didn't think of that, but yeah, good. Biologically, yeah, nucleic acids form DNA. DNA is an acid, deoxyribonucleic acid. Very good. So nucleic acids, DNA, they make the whole, our language or instruction manual for life is acidic. Good, so to understand that, Sid, Haber process. Just, again, recap it for us. You've done it multiple times already.
I have a is nitric acid the one you're talking about?
Yeah, so what happens is we make ammonia from the Haber process, and I'm sure you all know by now, we need it to produce nitrogen-based fertilizer in soil to grow crops and wheat to feed what's, I think, going to become an 8 billion population world, which is, I think, is insane. We're going to apparently, statistics say we want to get to 10 billion and then it's going to plateau because of resource limitations on our planet. Like, I don't think we are meant to go past 10 billion. And our frank reality, guys, is the whole reason COVID happened is because of overpopulation, right? There are too many people, too much proximity that allows disease transmission and allows pandemics to happen. So that's literally just nature producing pathogen and then working off the human population, which is quite crazy. It's scary. Like pandemics are going to happen much more frequently now, and that is a quite confirmed basis based on this. But anyway, coming back to this growing population, to actually feed everyone, we need to fixate nitrogen in soil. So what we do is we get the ammonia from the Haber process. We're then going to react it with nitric or sulfuric acid, and we end up forming ammonium nitrate. And this is a salt that we can directly add in soil. The plants can use the nitrogen and then create organic compounds from it. Does that make sense? Good. So a huge use case is using acids to fixate nitrogen in soil. So formation of nitrogen-based fertilizers. Any other use cases we can think of? Do we know what the pH of blood is? This is directly important for the HSC. Because this is an example of what we could call buffers. Does anyone know what the pH of human blood is? It's about 7.35 to 7.45. And what we actually do is we measure the pH of blood whenever a patient is sick, right? If they have a blood infection, if they've had a heart attack, if they've had a stroke, we measure blood pH. If they have a lung problem, literally for most patients that are very sick, I'll order a blood pH measurement to see what's causing the disorder. Because if it is outside of this buffer, enzymes in your body stop working. If that happens, it's really bad because chemical reactions slow down and they will die soon. So it's almost a proxy of how likely they are to get out of hospital. So you will learn what the exact buffer is, and that's going to be one of your exam answers for the HSC as well. So as you can see, you kind of need to be a little bit literate in acids and bases to really understand industry, chemistry, drugs. And I forgot to mention this as well. Every single drug in the pharmaceutical industry is an acid or base, right? So you will have no understanding of medicines itself if you don't know what acids and bases are. Good. So coming to this, we're going to skip all the verbs. You should have started to almost master some of these by now. Let's go to content focus. You can see now why I asked you so much about acids and bases. What is an acid? What is a base? You've already answered the inquiry question for me, which I'm happy with. What is IUPAC 1.1? I want you all to look at the first dot point here. Have a quick read of it, and then could someone tell me what IUPAC nomenclature is all about? Brownie points if you know what IUPAC stands for. Try not to search it up. Sid, what is IUPAC nomenclature?
Oh, it's just naming compounds, like using like a set system.
Yeah, good. Jacob, do you know what IUPAC stands for or is? Because when you go to Mod 7, you'll be using IUPAC to name every single organic compound they throw at you in your exams. So IUPAC, yeah?
I'm not too sure.
Yeah, so it's all about communication, right? I had a bit of I was questioning this a couple of years ago in medicine, which is, why do we call the humerus the humerus? Why do we call the radius the radius? Why do I have to remember all these weird, funky, fancy names? The reason is it's for communication. so we can all be on the same page really fast and communicate understanding of concepts. It's the same principle in chemistry. The reason you need to know how to name organic compounds is so you can communicate with someone else a very complex idea, or you can say one word which will elicit the image of a complex three-dimensional multi-ringed carbon structure which people can already comprehend and then apply and explain and understand. So IUPAC stands for the International Union of Pure and Applied Chemistry. They're the governing body that tells you how to name every single compound in chemistry. So IUPAC nomenclature is just all about, can you name basic acids and bases, right? That's not too bad. Let's come back here. So these are just a few properties of acids. I'm just going to talk about the ones we have not mentioned. We've mentioned they're corrosive because they can cause burns and skin irritation. And what that pretty much means is they will undergo reactions on the skin that will break down compounds, right? And then we'll feel it as a burn because it elicits pain. A bit about litmus paper. Litmus paper is it's from a plant. And what we do is we put the pigment on a strip of paper, and it can either be red or blue. And the way I remember this is when I think of acids, I think of the color red. When I think of bases, I think of the color blue or purple. That just happens to be because most indicators cause that kind of color change with acids and bases. So acids would turn litmus paper red, bases would turn litmus paper blue. That's just a very tiny point to remember. I've never actually used it, and I think it's quite useless because it's just rote learning, but it's good to just have as one of the properties. A very important one here is it conducts electricity. Let me just test your understanding of this. Nikita, can ionic compounds conduct electricity as a solid?
No.
Good. How about Sid? Sid, what about ionic compounds, aqueous?
No.
They can. Remember when they're aqueous, think about what happens. You just learned this, right? They're going to form ion dipole bonds if they're in aqueous state. It's going to break them into hydration spheres, and they can now move around. What conducting electricity means is when you apply an electric field, if any charge has a net direction of movement, that is electricity. The movement of electrons or charge is electricity, right? So if you have free charges like positive, negative ions, anions, and cations in an aqueous ionic solution, it will conduct. Ruthania, what about a molten solution? So if I've melted sodium chloride into a liquid, can that conduct? Yes or no? Give it a go.
No.
The answer is yes, because when you melt an ionic compound, it's got sodium, it's got chloride, it's got sodium. What you actually do at a bond level is you're breaking those ionic bonds of attraction. And now the ions are free flowing again. So key learning point here, ionic compounds can conduct when they're aqueous or molten. Okay? And acids and bases are literally ionic compounds that are aqueous. That's why they conduct. Does that make sense to everyone? Good. All right, we've already spoken about the uses. The reason I've also included aspirin is because you're going to do a lot of calculation questions with aspirin for this module. I can guarantee all of you in some exam through the next year, you're going to come across an aspirin titration or calculation question. Aspirin's a pain relief medication, and every single person with a heart problem will get put on aspirin for the rest of their life because it's quite safe and it also thins your blood. It's an acid, so that's why you get a lot of calculation questions on it. Quickly talking about bases. Bases are bitter, pH greater than 7. What is pH? One thing I haven't really emphasized for us. Let's go to Anne. What does pH stand for, Anne?
In all honesty, I don't know what it stands for, but I do know if it's 7, it's like neutral.
Good, good. And I'm actually going to flip that because you'll learn how complex this is. pH equals 7 being neutral is only at 25 degrees. You guys will learn water does not have a pH of 7 where the temperature is less than 25 or greater than 25 respectively. So one thing to remember here, and it will help you a lot with your later calculations, is pH is a temperature-dependent value. Like it'll change based on temperature. So just keep that in mind. But very good. pH stands for power of hydrogen. Power of hydrogen. And does anyone know what the equation for pH is? Because you'll be using it a lot for this next module. pH.
Isn't it that log base 10?
Yeah, negative log base 10 of the concentration of hydrogen ions in moles per liter. Okay, and just a very basic thing to understand for this is, of course, if there's greater hydrogen ion concentration, the pH will be lower. Okay, so that's just the inverse relationship we need to understand. So, of course, you know, acids release hydrogen ions. They're going to increase the concentration, and thus they'll have a pH that's lower or less than 7. Very good. All right. Can bases conduct? Let's go to Jacob. Can bases conduct electricity?
Wait, can you hear me?
Yep.
I'd say yes.
Yeah, good. I didn't put it here, but it's definitely right. Bases do conduct electricity. Very good. Same thing, guys. Remember the principle. If you have moving charge, especially when electricity is applied, you're conducting electricity, right? And bases have the OH minus ion that is going to move when electricity is applied. So very good. So here are just some use cases of bases. There are so many medications that are basic, to the point where we actually have to consider those things because it affects how things are absorbed and excreted in the kidneys and in the bloodstream, etc. Very good. All right, let's start talking about how to name your acids. And what I would say is, do not memorize this method. When you do enough questions and when you talk about chemistry enough, this stuff is going to be very easy, right? So don't worry about the steps to name an acid or base. It'll literally become muscle memory. For now, I'm just going to teach you what those steps are, okay? When it comes to naming an acid, first thing you need to know is whether it's organic or inorganic. What does that mean? Sid, what does it mean to be an inorganic acid?
It's not naturally occurring.
Oh, it's hard to say, right? Because like hydrochloric acid is inorganic, but it's naturally occurring in my stomach. I don't make it at night, right? So organic versus inorganic. It's probably marketing, which is why you guys are thinking of it this way. You know, natural or non-natural. Organic literally just means it contains carbon, hydrogen, and oxygen. Okay, so specifically carbon and hydrogen, those are the main two things. If it's got C and it's got a H, it's organic. Binary acids, or in this case, inorganic acids, they don't contain C and H. Okay, carbon bound to hydrogen. So talking about binary acids, example of those, this X is usually a halogen. So it'll be, for example, HCl, which I'm sure you all know is hydrochloric acid. And so you can start putting it together. The first name is always going to be hydro. It always ends in ic acid. And we just change the remainder based on the halogen that's used. So what would you call this compound here, Rithanya?
Hydrogen bromide.
Yeah, so let me help you out with this, right? So if you're stuck, name the entire compound. This is hydrogen bromide, but when it dissolves in water and becomes aqueous, it's an acid, right? So what you do is you take the gen out, so it's just hydro, and then you see how it's bromide here? We take the ide off and we put ic acid. So this is going to be hydrobromic acid. Okay, and your turn. What would you call this?
Be hydrofluoride.
Close. Remember, name the full thing. For now, name the full thing. So you call this hydrogen fluoride, right?
Yeah.
First thing you're going to do is take the gen off, so it's going to be hydro. And then you're going to change the "ide" to ic acid. So what would you call this?
hydrochloric acid.
There you go, right? And so Jacob, one more for you. This one's a little bit harder. What would you call this? Same principle.
So is it hydroiodic?
Yeah, it sounds weird, right? But you're completely right. Hydroiod, but instead of the "ine", going to be ic acid, hydroiodic acid. Very good. These are the main ones, right? There's HF, HCl, HI, HBr. Not many other halogens that we go through. So very good. Good. We'll continue naming acids and bases next lesson. But that's the principle. Like I said, you don't even have to practice this stuff. This is the ABC's bread and butter. When you do questions, you'll remember all of this. So you'll be fine for this. What I'd like you guys to do for next lesson, the lesson after, start doing as many trial questions for Mod 5 as you can. Test your knowledge. Any questions you find challenging, bring it into class. I'm more than happy to go through it. Okay? We're a little bit ahead for Mod 6. I'm happy for us to do some hard Mod 5 questions as well if you still feel a little bit weak in areas. Okay? The other thing I want you all to also understand is you learn this module first, so it's going to be in your mind for the longest time. So any weaknesses you have now, you have a whole year to fix it and improve. Whereas Mod 8, you're going to learn it fresh, and you're going to be sitting the exam very shortly after that. So that's why it's a little bit harder, and hence why I prefer us jumping ahead in terms of pace for the meantime. Good. Any questions? Jacob, question?
Yeah, I was just gonna ask. In the holidays, the class is still gonna run or no?
No. So what's going to happen is we're going to have the 10-week term end shortly. I'll confirm how many lessons we have. But after the 10 weeks, you guys will have a break, and we'll start likely towards the end of Jan. Probably around the 20th of Jan, we will resume, and then we'll go back to our 10-week terms. Does that make sense? Likely it'll be non-stop 10 weeks, 10-week terms. We'll finish quite early. Last year, we finished probably like 2 months before the HSC. Yeah.
Yeah, okay. Because my school's already started Mod 6, so I was just gonna ask you, like, in the holidays, how can I like get ahead for Module 6?
Yeah, so literally what I said at the beginning of the class, I want to give you all access end of the term to the Mod 6 notes, the Mod 6 trial questions. Go learn ahead, do the trial questions. You should be finished by Mod 6. That's where I expect you all to be at when we start class next term. And so that way, when I go through Mod 6, it'll be much, much faster. Does that make sense?
Wait, so just like read the notes and then do the practice
notes.
questions?
Yeah, exactly. Read the notes,
Yeah.
finish the practice questions. So I think I wrote it up at the very top here where I wanted you to be, right? Here. I want you to finish Mod 6, finish the Mod 5 trial questions booklet, and ideally finish the Mod 6 trial questions booklet. If you can get there, you're at a good pace. If you're not there, then you know you still have a bit of work to do.
Alright, and if we have any questions with like
Just send it
the
across,
actual
yeah.
questions, just ask you. Yeah.
What I would
Sweet.
say is, look, you guys are all really smart, and this is the benefit of being in a group class, right? If you have a question, first thing I'd do is post it on our team's channel. Just posting it, asking if anyone else can solve it. I'm sure all of you would benefit from that. Help yourselves. I think the thing you all need to like appreciate is if you're all very bright and hardworking, you will push each other to do your best, and you guys will be your reference range for performance. If you keep helping each other, you will differentiate yourself from the state. So do send your hard questions across. Then I'll also put my working out if no one else can solve it. Okay. Good. All right, guys. Have a good week. Stay tuned on Teams for our makeup class, but I will see you next week. Okay. Bye.
Thank you.
Bye.
See ya.
Alright, so yeah, thank you.
Bye, Jacob.
Bye.
Bye, Nikita. Was that your question?
Yeah, so in my exam yesterday,
Yeah. How was
they
it?
said I kind of overstudied, but yeah.
No, your report was really good, and I don't think there's such thing as overstudying. As long as you're confident you did well, you did good.
Yeah, so one of the questions were assess the economic benefits of the Ostwald process.
Ooh, okay.
So I wasn't quite sure if I should say pros and cons because it said benefits. Kind of just did it anyway.
What was the question? Verb, assess?
Assess. But it was only like 3 marks.
Yeah, I would mention cons too. Like in terms of economy, I would talk about pros and cons.
Okay.
Yeah. Did you mention
So
any
I-
cons?
Yeah, I did. But the thing is, on my case study, I only had like the economic, like how much was spent for each thing.
Yeah.
So I kind of
Yeah.
just made up stuff.
What did you say?
I just said, well, it was a nitric acid, so I said it improved profits in fertilizer companies and stuff.
Yeah, I think job, tourism, industry, economic benefits. I can't think of any cons because I haven't learned the Ostwald process in quite some time. Yeah, I wouldn't know any off the top of my head, but usually in terms of those economy questions, the pros are usually increased economic output, jobs. If it's like economic impacts, I guess if there's environmental impacts that can affect the tourism sector as well, there can be cleanup costs, medical impacts. Like you could also kind of link societal impacts as well in terms of yeah, but there's can't think of any off the top of my head. Let me know how you go for your exam, okay?
Yeah, sure.
Cool.
Thank you so
All right,
much.
Rithanya, see you next week.